Hello MIS 411 class. Welcome to Chapter 4, Video 3. This is going to be the first part, or the first in a series of videos on transforming EER diagrams into relations. In this learning objective, we'll be looking at transforming EER diagrams to relations, or in other words, taking the enhanced entity relationship diagrams we worked on in the conceptual phase of the SDLC and converting them to relations, aka tables. So there are 7 steps that we'll be going through, at least 7 initial steps in converting ER diagrams to relations. And really these will have to do with what entities, relationships, etc. you defined in the conceptual portion. So not every one of these steps will actually even apply to you. You can immediately see something like the unary relationships or ternary relationships. If you don't have those in your conceptual diagram, then you won't need to use those steps. However, whatever you do have across these different entity types, obviously you will need to go through the steps. And so the steps are, step 1, we're going to map regular entities. And by regular, I just mean entities. We could also look at those as just strong entities that don't have any other characteristics that make them different than sort of the normal baseline entity. Then we're going to map weak entities. We'll map binary relationships. As you recall, a binary relationship is just a relationship between 2 entities. We'll map associative entities. Hopefully at this point we're all pretty familiar with what an associative entity is. We'll map unary relationships, relationships between an entity and itself. Ternary relationships, which probably very few groups actually have, or very few individuals actually have at this point. And then we're going to map supertype and subtype relationships. So just some general rules for transformation, and I don't think that the book necessarily talks about these, and these are going to be specific to what we're doing in this class, and partly because we're going to be using Oracle, and so because of that, just for consistency with Oracle kind of best practices and what you'll actually see using Oracle a lot, we're actually going to use these, what I'm calling loosely rules. Okay, relation and table names should be uppercased. And use underscores instead of spaces. Okay, so you can see on the screen you have student major, relation or entity or table, and it's all uppercase, and we're using an underscore instead of a space between student major. Attributes, aka fields, aka column names, we're also going to uppercase and use underscores instead of spaces. Hopefully that's actually helpful. So essentially whether the object is the name of the relation or table itself, or an attribute slash field slash column, we're always going to do an uppercase, use underscores instead of spaces. You might see other formats where people do what's called camel casing, where the first letter will be uppercase and then they'll abbreviate a word, and then there won't be spaces or underscores. The second word will be kind of just jammed in, but I think that might be overly complex for what we're doing. So these are the rules that we're going to follow for this class at least. Primary foreign key designations should be done in the left column of the entity or relation, and the primary keys should be underlined. There should be no notation of composite, multi-valued, and derived attributes at this point, right? So I shouldn't see, square brackets, I shouldn't see curly brackets, I shouldn't see parentheses in the attribute names. If there is more than one foreign key, they should be numbered. So we want FK1, FK2. So again, looking at the diagram on the screen, you can see that student major actually has one primary key. Now, of course, right, every relation slash table, every table will only have one primary key, can only have one primary key. It can have 0 or more foreign keys, right? So student major, when you're looking at your screen, has one foreign key, student ID, going to the student relation, and one foreign key, major ID, going to the major relation, right? And so because of that, I'm labeling them FK1 and FK2. Step 1, mapping regular entities. So here we're going to dive right into the process of mapping a regular entity. And again, a regular entity just refers to, say, a strong entity with nothing particularly special about it. It's not a supertype, subtype, it's not an associative entity, etc. Right? It's not dependent upon anything else, so it's not a weak entity. Okay? And so for the purpose of this demonstration, we're going to be looking at an entity that we call student. You can see in the conceptual sense we have ID as the identifier, we have a composite attribute, address, we have a derived attribute, age, and we have a multi-valued attribute, major. And also notice at the bottom, so I'm going to show in the previous video, I think I mentioned there's different ways to represent these relations, and obviously one way is to do it in this form, like so, kind of as we've done with the entities, and the other way, sort of the shorthand one-liner way, is to do it in this form. So I'm going to be showing both of these as we go through this process. So step one is for each regular entity, create a relation of the same name. So that's pretty simple. So we started with a student entity, and we created a relation called student. I did it in this format, and then here as well. Step two, the identifier of the entity becomes the primary key of the relation. So we had an identifier. As you can see, it was underlined in student. So now I have a primary key. I leave it underlined, but I also am now placing the letters PK, right, standing for primary key in our relation. Down below in the relation shorthand, I have an underline also identifying it as a primary key. Step three, for composite attributes, create separate fields for each part of the attribute when creating the relation. So we had a composite attribute in the student entity, address, composed of street, city, and state. So in the relation, we're going to actually break that out. We'll no longer have an address field, right? Now we have street, city, and state as separate fields of this relation. Okay, also down below, street, city, and state. And then finally, perhaps the most complicated part, for a regular entity at least, is for each multi-valued attribute, create an additional relation containing two fields, a foreign key reference to the first relation's primary key, and then the multi-valued attribute value itself. All right, and the two fields in the new relation should together form the composite primary key of the relation. So that's a lot of words, so let's look at it in practice. So I had an entity, student, right, and let's say that we said a student can actually major in one or more majors, right? A student could be double majoring. They could be in Spanish as well as computer science, right? So I start with the relation student. Up to this point, it looks all the same, right? But you notice I don't have a major field in this relation, right? In the entity, I had a major field, a multi-valued. In the relation, I do not have a major field. I create, because it's multi-valued, I create a major relation table, right? And as noted, the two fields in this relation are a foreign key reference to the first relation's primary key. So here's the foreign key reference. I have student ID. It's a foreign key referencing the ID in the relation, which is the primary key of student, right? As well as the multi-valued attribute value itself. Okay, and so that would be the name, i.e. computer science, etc. The two fields in the new relation should together form the composite primary key of the relation, right? So student ID and name are both part of the primary key. Now you notice that name is not a foreign key, right? Only student ID is. But both fields together are part of the primary key. Down below you can also see that in the shorthand notation I've created this new major relation, right? Student ID and name are both underlined. As I mentioned in a previous video, the fact that student ID is also a foreign key, if it was only a foreign key and not part of the primary key, it would be a dashed underline. But because it's both, the primary key notation takes precedence, so student ID and name are both underlined, and we can see a reference back to the student relation. So in practice, what would this look like? Let's say we populated these two relations. And again, I'm going to use the words relation and table sort of interchangeably. At this point, we really are talking essentially about database tables. So let's say that we populated the student table and the major table, right? So I have these three students, various IDs, various names, dates of birth, street, city, state. Age is derived, and we'll talk about this a little bit more. It's the preview is essentially the age could actually be defined inline in the table itself, or we could just calculate it every time we pull data out of the table. It really is maybe a design decision that you'll have to make for yourself, but let's not pay too much attention to that for now. We also have the major table, right? And we've populated that as well. And so what do we see in the major table? Okay, we see Delilah Humphrey, right? Student ID is 123, 123, 123. I see 2 rows for Delilah in the major table. So Delilah is majoring in literature and writing, LTWR, as well as Spanish, SPAN, right? Thomas Jansen is ID 634, and I see that Thomas is majoring in Spanish as well as Delilah, and Econ, right? And I see Regina Lott, and Regina only has 1 row in here, and Regina is majoring in computer science. Now, just because it's multi-value does not necessarily mean, number one, that that someone has to have more than one value, right? Some people are just majoring in one thing. And the fact that it's multi-valued or that we've created this other relationship, doesn't compel a student to actually be in here at all. We could have a fourth student who has no entry in the major table. There's nothing at the database level that's going to enforce them having a row in here. Or in other words, the database itself, at least with this design, will allow the student to not have a major at all, right? So some things will need to be either handled at the application layer or with additional logic built into the database, not here, but maybe with a trigger or something along those lines. But for now, it's sufficient for you to understand that this design does not mean that every student will need to have a record in the major table. So let's also talk about some of the reasoning behind why particularly the composite attributes are expanded as they are and the multi-valued attributes are expanded as they are. I think it's pretty self-explanatory that we're going to create a relation of the same name. You know, why would we change the name between the entity and the relation? And I think it's pretty self-explanatory as well how we've identified the primary key. We did obviously say that this was going to be the identifier when we were looking at the conceptual diagram, an attribute that would uniquely identify a particular instance, right? So of course that should also be the primary key. But why do we blow out the composite attribute? Why not just keep address as one field, right? And the answer really is for data retrieval purposes and for reporting purposes. Let's say that we only had one field. It was just called address, and it was 123 Elm Street, comma, Escondido, comma, CA, comma, 92025, right? And let's say someone said, hey, I want to get a list of all individuals who live in Escondido. Now the problem is the address field would have Escondido multiple times, right, for multiple people, but instead of it being its own city where I could say city equals Escondido, I would have to do string logic, right? And you've seen some of this before. I'd have to use a like command, or I would have to use a substring. And in general, breaking out the composite attribute into separate fields allows us to more sort of cleanly get at the data, right? Same thing for state. If state was just sort of intermingled in one long text field, it becomes more complicated, not only from the perspective of a SQL query. You might think like, well, a like isn't that much more complicated, but it adds a little bit of complexity, and also there's a performance implication as well. In most database systems, they're going to be more easily able to retrieve data when you can do an equality type, as opposed to doing a like or doing a substring or adding a lot of functions. So that's the primary reason why we break out composite attributes, is essentially for data kind of cleanliness, for data retrieval. Okay. Now the multi-valued attribute is kind of an interesting one, and I think I touched upon it in a previous video. And the issue is that because we have this row in student, for instance, right? Let's say that Delilah has not one, not two, but let's say that Delilah has 3 or more majors. I don't know how that would happen necessarily, but let's just say we have a multi-valued attribute where that person could have 10 of a thing, right? Now, how would we represent that in a single row for Delilah? Or, failing a single row, if we didn't do it in a single row, how would we do it in such a way that Delilah we could have a unique identifier, okay? And the issue again here is that one option would be to have 10 fields, major 1, major 2, major 3, major 4, major 5, etc., and have many of them blank for most people. Now the issue there is kind of twofold. One is that it really blows out a table, especially if most people are only going to have one major, right? Having 3 or 4 fields makes it a little bit messy, right? Because we're going to have a lot of empty fields for a lot of individuals. And let's say we weren't talking about major. Let's say we're talking about something like languages or skills, or something where someone could have conceivably, unlikely, but some outliers may have like 15. Someone may speak 15 languages, right? How many fields do we place into the table? It's not easy to go back into a table and change it all the time every time you get some new data, right? In terms of the columns and the field lists. So that's not a really scalable solution, right? Representing multi-valued attributes typically as multiple columns is not a scalable solution. We may do that from time to time if we know, beyond a shadow of a doubt, that there's only going to be up to 2 or 3 of a thing. Sometimes we will, in fact, just create a separate field for each one and be okay with the fact that many of these fields will be empty for many individuals. but more often than not, that's not going to be a viable solution. So what's another solution? We could create multiple rows, right? But the issue here kind of is, well, I mean, there are a couple different issues of this. One is you get a lot of redundancy. Let's say that we were talking about languages again, and I created one row per language per person. So let's say Delilah spoke 15 languages, right? Now I would have 15 rows in here for Delilah. Each one of them would be exactly the same except for this one language column. One language column would say English, one would say Spanish, one would say French, etc., right? So the redundancy of that becomes problematic for many reasons, and we're going to talk about this more in a normalization section. But the other issue with that is it makes this table more complex to query from. Like right now, if I only have one row per student, I can do a very quick count, right? I can say if I have 50 rows, I have 50 students, right? Once I don't know that that's the case anymore, once I know that some individuals may be represented multiple times, then I have to do much more complex logic to pull it out. Okay, and again, we'll talk about this more in the normalization section. But this is kind of the most elegant solution, essentially, that we have, which is really to break out any multi-valued attribute into a new relation, into a new table, and then to have it referenced back using a foreign key to the original table. So now that we've completed step 1, mapping regular entities, now we move on to step 2, mapping weak entities. So you may recall that a weak entity is one that cannot exist in a diagram unless there is a strong entity with which the weak entity has an identifying relationship. And simply put, you can see on your screen, this is an example of that. You cannot have a class section, a specific offering of class, without actually having a class. And so just to give an example, a class might be, Computer Science 101, right? But you might have multiple class sections of that offered by different instructors at different times of day, right? And so you can't have that class section if you don't have that class. And so this is an example of a strong and a weak entity. You can see that I put the double line between class and class section. That's the identifying relationship, if you remember how strong and weak entities work, just so that it's understandable. I should have double underlined the section number as a partial identifier, but to be honest, diagrams.net was giving me some issues. So just imagine a double underline there. You see how I left a space right under class section, between class section and section number, and that's to represent essentially the main characteristic of a weak entity, which is that the partial identifier for the class section, in this case, for instance, the section number, in and of itself is not sufficient to uniquely identify a class section. What it requires in addition to that partial identifier of section number is the reference to class, right? That is to say, you might have many class sections with the same section number, right? Because you might have CS 101, section 1, you might have Math 101, section 1, you might have Econ 101, section 1, right? And so the section number of 1 isn't sufficient to give you a class section. You also need to know which class it's referring to. And that's, fundamentally what a weak entity is. And we've studied this before, so I don't want to belabor the point. Step 1 in this, essentially, is when you have a weak entity, and you obviously will have a strong entity in addition, the first step is going to be, just like with the regular entities, follow the same steps. And what that means is, what we'll do first is we'll take the strong entity and the weak entity, we'll take their names, we'll create new relations, i.e. tables, right, with the same names. So class goes to class section goes to class section. The regular attributes, subject, number, instructor name, all come down as regular attributes. The only change really is that we're following the naming convention that we discussed, which is uppercasing all the attributes and using underscores instead of spaces. With the strong entity, this is obviously also a regular entity, as we described earlier. We have the ID as identifier, and now we create that as the partial key, or the primary key, sorry, not partial key, the primary key. And with class section, like I said, this is really should really be a partial identifier. I've moved it down temporarily. This is not a complete, so obviously there are more steps that we need to do with class section, but I've temporarily moved it down as part of the primary key, and I've left this space to kind of indicate, the space right here, to indicate there needs to be more primary key. This is in and of itself not enough because it's a weak entity, right? And down below I'm using the other notation as well. We have class, we have ID subject number, ID's underlined to indicate its primary key. Class section has the double underline, which I should be here as well, indicating it's a partial identifier along with instructor name. So the next thing we're going to do is we're going to add a foreign key reference to the strong entity in the weak entity. Okay, so what we had was basically what we had was this, right? Primary key, section number, instructor name in the class section. And now what we have, primary key, section number, instructor name, and we also add a foreign key to the class ID, right? So that foreign key class ID obviously references the class ID. Down below you can also see the class ID is the dashed underline, meaning it's a foreign key, and the class ID is referencing the ID. Okay, and then finally there's this bit. And this ultimately is going to come down to a design decision. So up to this point, we really haven't had a sufficient primary key for class section. Even the section number, as I said, is not really a primary key. So this is not this is not its final form, so to speak, right? So we have two options, essentially. One is to use what's called the natural key, which is where the primary key is a combination of one or more attributes from the weak entity, as well as whatever foreign key we're using to the strong entity. Okay? And so this is called the natural key. And so what you can see here is the primary key here is now composed of the class ID, which is the foreign key reference to class, as well as the section number, right? So that becomes a what? A composite primary key. And down here again, you can see how I've represented it. Both get underlines indicating they're both part of the composite primary key. Class ID is also a foreign key, but as you know, the primary key notation takes precedence, so I'm not doing a dashed underline. And of course, instructor name is still just regular attribute, so it's below the fold. But the other option is to generate what's called a surrogate key. Now, a surrogate key, you might say, well, we never had, where does ID field come from? And this is something we would simply generate as generally an auto incrementing a number. So the first row we get in class section, we would give it a 1. Second row, we would give it a 2. And so we would be in control of just giving it an arbitrary increasing number and never repeating that number. And so consider the difference here. This is called a surrogate key, right? So with the natural key, I have the class ID and section number, which together combine to create a composite primary key, right? If I'm using a surrogate key, the class ID is still a foreign key, of course, because it has to reference class, right? The section number is no longer a key at all. It's still an attribute. It's still a valuable field. We still need it, but it's no longer a primary key. It's no longer part of the primary key. And the entirety of the primary key is now just this one ID field. And again, in this notation, you can see it here. I have the ID field, which is the surrogate key. I have the class ID, which is dashed underline because it's still a foreign key. And obviously, just as an aside, don't pay where these line end up doesn't mean anything, right? This is just consider this relationship between this relation or table and this relation or table. It doesn't really matter where they're aiming. In some cases, I think people will try to line them up, but for our purposes, don't consider this to be of any relevance, like where it ends on the box. So as I was saying, so this would be a surrogate key, and everything else kind of remains the same. But section number obviously is no longer part of the primary key. And so then the question becomes, the obvious question is, when do we choose a natural key or surrogate key? And to be honest, this is kind of a design decision. Different people have different approaches. Oftentimes, the decision to use a surrogate key is based on how complex the natural key would be and whether you think it's going to change. The truth is, my personal approach, and I'm not saying that you have to abide by this, my personal approach is generally to create a surrogate key. I find it simpler. I like kind of having that sort of single ID field as opposed to needing to reference multiple fields in order to get a primary key. That's my personal approach. You can use that or not as you see fit. So what do we end up with after we've converted everything to relations? So here we have the class relation table and the class section relation / table. As you can see here, I've opted to use a surrogate key for ID for the primary key, right? I'm using the surrogate, which means that I would generate just an ascending number, an incrementing number for each row, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you chose to do so, you could actually just use the class ID and section number combination as the natural ID. our natural key, as we discussed. Really, again, it's a design decision, so it's up to you which direction you go with that. So what do we see? We see the class has an ID. We have CS101, for instance, has ID 5, and we can see that we have 3 sections of class ID 5 of CS101 taught by 3 different individuals. We have class ID 23 is Spanish. We have 1 section of that. We have class ID 56, which is Econ 395, and it looks like that's not being taught. And so in this way, you can see that we've now developed essentially 2 tables that relate the classes and class sections in such a way that they conform to our original conceptual diagram. But also crucially, in the original conceptual diagram, obviously with class section being a weak entity, we didn't have a primary key designated, and now we do.